Hello friends, welcome to our channel Physics for You, and in this video we are going to learn the last topic about the viscosity, that is the experimental determination of coefficient of viscosity by Poiseuille's method. If you remember, in the last video we have seen how to derive the Poiseuille's equation, and now that equation we can use to determine the coefficient of viscosity of liquid. So for that purpose we need to do one experiment, and if you do that and if you get all the parameters required in Poiseuille's equation, then we can easily find out the viscosity, moreover the coefficient of viscosity of any liquid. Okay, so as you can see on the diagram which is shown on the screen, we have to take a capillary tube of very fine bore, and it has to be connected with the help of rubber to the vertical burette, or we can say the vertical vessel. So whatever may be your experimental liquid for which you want to calculate the coefficient of viscosity has to be filled in that vertical burette or vessel as shown in the diagram. Okay, and yes, our capillary tube has to be taken vertical horizontal, and which is connected to the that vessel through a rubber tube. Okay, now the burette is filled with the water and the pinch stopper is removed. That means whatever may be, already we have a pin which is used to stop the flow of water at this point, we can say. And as soon as we remove that pin, what happens? If you remove this pin, then the flow of liquid will start. And yes, the capillary tube's bore is very what we can say narrow, therefore the liquid is coming drop by drop from the vessel, and you have to collect that liquid also in a beaker. Let us take a beaker and keep here, so that whatever may be the liquid coming from that capillary tube drop by drop has to be collected in a beaker. And at the same time we have to start the stopwatch. That means you have to measure the time also. So you can take it for 2 minutes, 5 minutes, whatever may be, because at the last we have to find for per unit second. So if you take it for 60 seconds, then you have to divide finally by the 60 and all. So you can take for 1 minute maximum, right? For 1 minute we can take the reading. So time we can say it is 1 minute, that means 60 seconds. So let us have a flow of that liquid by removing this pin which is already fixed in the capillary tube for 1 minute, and let us see how much will be the water collected after 1 minute through that capillary tube. So we have to measure that also, what is its volume in ml. And now see, initially the height of the liquid was h1 before starting the flow of liquid through the capillary tube. And let us consider after time 1 minute or after time t, the liquid has dropped its height and it comes to the height h2. That means initially it was at point A as shown in the diagram, and finally when we stop the flow of water, then it comes to the point B which is at height h2. Okay, now okay, so right now now we know, as we have seen in the previous video, we have derived this equation. That is what, if we have P is the pressure and R is the bore of capillary tube, and if eta is the coefficient of viscosity, and yes, obviously the length of the tube has to be measured. Which tube? This capillary tube. How much is the length? So if L is the length of the capillary tube, and then if V is the volume collected, within time t, then we know volume collected per unit time can be written as, or that is what we have found out in the previous video. The link of that video I will post in the description box of this video. So you will understand how this formula came. So this formula is simply to get how much volume collected within per unit time. So P pi r power 4 divided by 8 eta L. Eta is coefficient of viscosity, R is radius of bore of capillary tube, P is the pressure, and L is the length of tube. Pi and 8 are constant. Okay, so finally we have to use this formula. Okay, right. Now what I said, for certain time we have to flow the liquid through that water and get this height difference also, initial height and final height. And yes, the time has to be noted, and how much is the water collected, or what we can say the volume of the liquid collected, that has to be measured. And yes, initially we have to find the bore of capillary tube also. That means once you went to this experiment, first thing you should know the radius of bore of capillary tube, that is our small r. And now let us consider the liquid you are using, or for which we have to find the coefficient of viscosity. Its density is rho. Then then the initial pressure difference between the ends of the tube we can calculate. Pressure initial height was h1, so we know the pressure will be h1 rho g, that is what we call the P1. And if we stop, that means the final height. So I will draw here one more diagram. So let us consider initially the height is h1, we have already seen, and the second height, that means final height is h2. So obviously pressure we can write in terms of height rho g h. So we can say initial pressure P1, that is rho g h1, and final pressure P2, that is rho g h2. Rho is what? The density of liquid for which we want to find the coefficient of viscosity, and g we know it is 980 in cgs, centimeter per second square, our acceleration due to gravity. Okay, so these are the two pressures, initial and final. Therefore we can find the average pressure. So the average pressure is simply P1 plus P2 divided by 2, and finally we can write the average pressure between the ends of that capillary tube, it is P1 plus P2 divided by 2. Okay, now if we substitute the P1 and P2 value, rho g h1 plus rho g h2 divided by 2. So we know that all rho and g are constant, the density of liquid is going to be constant, g is constant, this 2 is constant, it is simply h1 plus h2, or we can write g rho, okay, h1 plus h2 divided by 2. Now this h1 plus h2 by 2, again it is what? The average height we can say, so we can write it as h. So this equation, that pressure is h1 plus h2 by 2 rho into g, but this h1 plus h2 by 2 is nothing but h, that is what average height. So rho g h will be the pressure. Okay, so you can see as we have written in equation 1, we want pressure. So once one thing is we clear to us, pressure we got it, it is simply rho g h. H we have to find by taking the average of those two heights. Okay, now if we substitute this value in equation 1, so equation 1 actually becomes here, now in case of equation 1 we will get pi rho g h into, instead of p we have written, so already equation I will write here, equation 1 was like this, p pi r power 4 divided by 8 eta into L. Okay, now instead of this p we can write rho g h. So rho g h pi r power 4 divided by 8 eta L. Okay, now this is what? Volume collected per unit time, volume of the liquid collected per unit time. But what is our target? We want to find the eta. So we can rearrange this equation as eta is equal to, now bring this eta to that side, and eta is equal to, we can write here pi h rho g r power 4 divided by, that volume goes into the denominator, right? So 8 L V, and this time will go to the numerator. So this is what we can say the final formula by which we can get the coefficient of viscosity. Now see here pi, let us substitute its value 3.14, h whatever may be the height h1 h2 its average, rho density of the liquid, it is already known to us, g 980 for CGS purpose or 9.8 in MKS, r radius of bore of capillary tube, t for the time for which you have taken the, or we have allowed that liquid to flow through the capillary tube, L is length of the capillary tube, and V is the volume collected in ml, right? So it is a very simple experiment, you can perform it at your home also. Let us take one transparent what we can say vessel, attach a capillary tube of length L, and note down the initial height and final height. Okay, and if we know we can find the average height h1 plus h2 by 2, and again obviously when the liquid comes or fall down into some beaker, just measure it whatever may be the volume. So you know the volume, you know the length, then height, and yes obviously the density of the liquid has to be known, and firstly we have to find the bore of capillary tube also. That can be done using our traveling microscope. You can focus the traveling microscope on the capillary tube bore if we have like this, and having cross wire at horizontal, vertical cross wire at one end, this at once at the left end and at once at the right end. You can get the diameter by taking the difference of those two readings, and d by 2 we can get the radius of capillary tube very easily. Once you know all these things, substitute everything in this formula and get the coefficient of viscosity of any liquid at by using this simple experiment. Okay, now for what purpose we require this coefficient of viscosity? That means, yes, obviously you might have the question, you are doing all these things, we are getting coefficient of viscosity, but what are its application? So yes, coefficient of viscosity, knowing the coefficient of viscosity of any fluid or liquid is important. So by using this or if you know this, then simply you can talk you can we can say the knowledge of coefficient of viscosity of organic liquid is used to determine their molecular weights. If you want to find the molecular weight of any organic liquid, then you must know its coefficient of viscosity. It is easy to find the molecular weight. And second important application is what? If we know the coefficient of viscosity, then obviously at various temperatures also you can have the temperature effect also, means you can perform the this experiment at different temperatures of that liquid, and you can have the variation of that coefficient of viscosity of the same liquid, same fluid, but at varying temperature. That is also important. So we know this fluid or these viscous liquids are used for different machines, mechanical things, or in industry for as an lubricant. Okay, so if you know it's a coefficient of viscosity, some machines gets hot when they are working. If we are having very smaller machine like our clock, okay, so for clocks it is not that much frictional force there, therefore we can use here the fluids with less what we can say, or the low coefficient of viscosity. But heavy machines in industries and all, or what we can say in vehicles, where the temperature goes increasing as the machine starts, then we require the material with a high viscous nature, that means with high coefficient of viscosity. And there for example we can use the grease and all. So that means if you know the coefficient of viscosity of grease and for how much temperature it sustain and all these things, if you know, so you can betterly use such materials for more complicated machines in industry and in mechanical what we can say purposes also. Okay, so this is what real life and very purposeful application of knowing the coefficient of viscosity. So this is what my small effort to know you about the coefficient of viscosity, and you can find it in this matter very easily. Okay, so if you have doubt, you can post in the comment box. Otherwise, if you feel this is value addition to your knowledge, then like this video. For more such videos, subscribe to our channel and press the bell icon so that you will get the notifications of my future videos, right? So thank you friends for watching this video. We'll meet in the next video with new concept. Actually this is the last article from the topic viscosity. We'll meet in the next video with some new concept. Till then, take care, keep watching and keep learning. Thank you.